Hello everybody, good morning. Okay, how are you doing? Yes, so today we will go with the third course and third session. And as I told you yesterday, we will start by doing quiz. So it's not complicated. So it was a joke yesterday. So it is only a way to make sure that you understood the content and that you can be ready to do your exam if you want to do it, certification exam, I mean. Okay, so yes, you are right. I think it was that we have only 3 hours, not so I thought that we have 200 minutes, but yes, but it's the maximum we can use for the session. Okay, so today it will be a shorter than the previous days. So what we will do before starting the third module, maybe you can start by doing the quiz. I don't know if you have access to the quiz through the platform. Not yet. So let me open it for you. Okay, now I think the quiz is available for you. Could you please confirm? And you also have it here. Okay, Herzog, Hena, Theo, Amin. So you have between 10 and 15 minutes to do the quiz. Okay. Okay, good, Watara. Okay, Herzog. Okay, so you have between 10 and 12 or 15 minutes. Okay, you have the quiz is also available on the e-learning platform. Okay, I just give the right to see it, and also available here directly. So as yesterday, okay, so go ahead and I will let you 10 minutes to do it. So it is 20 questions. You have to select one correct answer, okay? Except if I tell you, for example, choose 2 questions, 2 correct answers, then you have to follow the rule. Sorry. Okay, so between 10 and 12 or 15 minutes to do the quiz. Okay, Lisa. Okay, yes, in the platform. You can do quiz 2. Is it okay, Lisa? Okay, let me see. Yes, it is available for you. Okay, on the platform, and you can see it here too. These questions are really inspired from the official exam, okay, certification, professional certification. So there is easy questions and other questions are more difficult, but usually this is the way they are asking questions. And many of these questions are already in the official exam, certification exam, CompTIA exam, RFID Plus. Please just tell me if you finished. Did anyone finish? Not yet? Okay. So please, it is not an open the book test, okay? So just try to do it without seeing anything about the content. So keep your documents and other stuff away, and try to do it only with your knowledge. Okay. So maybe two minutes more, then I'll be with you. Okay. So is it okay? Can we start the correction of the quiz? Okay. Everyone is okay with that? Okay. So first question, which of the following is the communication method used by microwave RFID? So, okay. Yes, B, Herzog, B. B, because when you increase the frequency, you do not use the magnetic field, or so it's easy to use the backscattering because it's not possible to use magnetic when you increase the frequency, because usually when you are using coils and magnetic, it is low frequency. Okay, so microwave is very high frequency, so B is the correct answer. The kill command of an interrogator is used to disable tag. Okay, so B is correct. All of the following are functions of an interrogator except communicating with another interrogator, communicating with a tag, communicating with a host computer, storing information about an item to which the interrogator is attached. So Sayyid Mohammed Sidi هنا A is a D. Okay, so I will go with the majority. Okay. Okay, Hina, it's yes, it's D. Because the reader can communicate with another reader with a tag, of course, it's obvious, with the host computer, yes. But the reader, its role, it's not to store information. Okay. So correct answer, because we have except here. Okay. Fourth question, all of the following are the configuration settings of a reader except. I see all the possibilities. So I have E, I have C, I have D. Okay, this question belongs to the official test, certification test. Okay, so I have 50-50 for A and C, right? So anyone else for guessing? You can understand that it's not the right answers I got. This is why I'm waiting for the right answer. That population that need to be read, it's the role of a reader. Anti-collision protocol, it is the role of the reader because he manages the anti-collision. The power emitted by the reader, yes, it manages the power emitted by it. Okay, so what is the right answer is B. Okay, the tag read rate, it's not an important parameter, and this is why it is not included in the features of the readers. So the rate of reading, it's okay. It's the rate of reading is as fast as it is possible. So so note that we have except here. Okay. So all the configurations of a reader are provided here, and this one is not a special feature of a reader. Okay. So the correct answer is B. Any comment, any question about that? Okay. Are you convinced about that? Okay. So the fifth question. You know that an interrogator zone at your site always get items with class 0 tags attached to them. You have noticed that the read rate of this zone is not that great. So what can you do to increase the read rate? So I have A, increase the power of interrogator to maximum, set interrogator to search for all tag class except class 0, set interrogator to search for class 0 tags only, and set interrogator to search for all tag classes. This, I remember this question, I have it in the official certification test. So I have A, I have D, majority A. Anyone else to give me the right answer? Because it's not the right answer. So it's not a question of power, because the power is regulated, so you cannot increase. And I have D. It is already searching for all classes, Hina. Yes, Herzog, it's the right answer, C. C. So when you are sure about your tags, you know that you have items with class 0 tags. You have only this class. So to optimize the reading, you just configure your reader to read only class 0. So you don't waste of energy or waste initiating programs or codes to search for class 1, 2, 3, because you know that you didn't have these classes. Okay, so the logic is to search to set C, to set interrogator to search for class 0 tags. Okay. Okay. So be aware about this type of questions. All of the following methods will help prevent overlap. I told you yesterday that there will be tough questions sometimes. Okay. All the following methods will help prevent overlap of the interrogation zone, except A, positioning the interfering antennas away from each other. Readers are configured to use different protocols, reducing the interrogator power, and setting the interfering interrogators to operate at different frequencies. So you have a problem because you have a overlap of the interrogation zone. Interrogation zone or reading zone is the same. Okay, we said yesterday, we saw yesterday that we provided the definition of read zone. It's same like interrogation zone, so you can have a space where your tag can be read. Okay, so the right answer here, you have exception except, so you have correct configurations and then you have one exception. Good, Mohammed. Good, Watara. Yes, it's B. B. Because when you analyze this question, you have overlap. So what you will do, you will position the interfering antennas away from each other, if it is possible, of course. But you have to check this. Then you reduce this is allowed to reduce the power. It's possible because if you have overlap, so you can design your space or your shape, the shape of your interrogation zone in such a way that it is not needed for power. So you save power, you save costs, and then at the same time you will avoid the overlap. Okay, so it is good to check if you can reduce the power and keep the interrogation zone as you want and according to your needs. Okay, setting the interfering interrogators to operate. Yes, if you because you saw yesterday that we have channels and we can we have many channels in France, Europe. You have in UHF RFID 10 channels. So if you have just 2 or 3 readers, you can tune each reader to operate in a given independent frequency from the other. Okay, so the remaining situation is that the readers are configured to use different protocols. It's not clear what protocols. Why protocols? So this is not a clear procedure to avoid the overlap. So B is the right answer because it's the false one. It's not the correct way to avoid the overlap. Is it okay with you? Okay, guys, huh? Okay. Very important because these questions could be in your final exam. So just remember and just keep try to capture the logic behind the questions. Okay. Very easy. The 7th one. What is the most commonly used RFID frequency in the low frequency range? Yes. Yes, here is the kilohertz, and don't forget. Yes, good. C. So the 8th question: what is the purpose of for regulating the power emitted by the antenna of an RFID device? 8. So to avoid interference with the RF wave from other devices, to save energy, to help the environment, to avoid disturbing existing radio frequency services. The power emitted by the antenna. The power emitted by the antenna of an RFID device. So if I regulate this power, what is expected? What I am expecting after regulating the power emitted by the antenna. So just capture the logic. Save energy. It's not help the environment. Yes, it's not so critical like B. Save energy. It's very general. So maybe it could be A between A and D, but between A and D, yes, Mustafa, it's E. Why? Yes, Lisa, yes, E. Why? Because so you have already the radio frequency series, and if you remember that you can have destructive and constructive interferences, and the antenna is a receiver of this. Could be the receiver of these waves, and if you increase the power, you will increase the gain of the antenna, the read range of the antenna. So, and you increase the risk to have the disturbance coming from the other devices. This is why by regulating the power emitted by the antenna, we avoid interference with radio frequency from other devices. This one is the most complicated questions, but A is the right answer. But I am not sure if in our exam I maybe I will accept the D answer too, because it also avoid disturb existing RFID surfaces. But here you have the other thing is that here you have radio frequency services. This is not clear. What is the meaning of radio frequency services? Here is device, it's more clear. Okay, so you have to read each word, okay, to be sure about your answer. Here, even if you have just a little doubt about your a word, or if it is not clear, it means that it's here for just as a false answer. Okay. So here we haven't devices, we haven't waves, we have radio frequency services. Radio frequency services, it's not so common as word. Convinced or not? Okay with you? Okay. Yes. The ninth question, an EPC number typically contains all of the following fields, except, so remember your memory. ICC, these are B, C. CC. Okay. I think I will go with the majority of people. So the right answer is B. Okay, just let's see the EPC code. I don't know if I have it here. Just to let you. So please go to see the EPC code and the fields of the code. So the CRC is not included into EPC. Impossible. It's besides. Okay. This is why it's impossible to be B. The EPC number does not include the CRC. It's in the bank 01, but it's another field. It's an independent field. Okay. So the header, the manager number, and the serial number are included into. So except is for the cyclic redundancy check. Okay. Did you check this? Are you okay with that? So this is a trap. So be aware. I told you it's very important to be very precise. It is in the same bank, but it's not included into the EPC. Okay? Okay. The 10th question, matching. So you have the kill command, the log command, the query command, and the read command. It's a very common sense. Here you can just match kill A for 2. Yes. A for 2. What are A for 2? Okay. Kill is to disable permanently. Okay. And lock is disable writing, verrouillé. Okay, B1, yes, B1. C, query, it initiates a communication with the tag. Yes, C4 and D3. Easy. Okay, easy. Okay, now you are installing an RFID portal on a door through which pallets will be passing. Which of the following is not necessary step to take in applying safety? Yes, I see B. Other responses? Lisa Herzog, Hina, Omen B. Amin. B. D. Ensure that safety regulation. Yes, but you have to see the most logic answer. So not necessary step. Not necessary. Ensure that the installed system conforms to safety regulation. It is necessary. Okay, so B, yes, B is the right answer, because we cannot tell to security guards to sit to change location. It's not professional. If you have if you design your network correctly, you will not be obliged to tell to persons to go away or something like that. So if you have a correct design. Okay, so this is B. This is also a classical question in the professional test, RFID class. Okay, very easy. UHF RFID frequencies in Europe are Herzog UCC. No, B. Okay, B for France and Europe. Okay, UHF. Okay. B. 13. What is the technique used by an RFID printer from this? RFID printer, not regular printer. Yes. There is no thermal printer, Theo. You have direct thermal. Okay, so E is the correct answer. No, Hina. Direct thermal. So please see your document. Okay. What is be very precise in your answer. Okay. So even if you have just one word, it's not correct because you need the two words. Okay. So just not wipe on Muhammad. So this is by seeing your document and then you will be okay. So what is the technique used by the applicator? What is the technique used by an RFID applicator? Oh no, not C. C it's no. The technology, yeah, used by applicator. You have two technology. Maybe technology used by the RFID applicator. Yes, pneumatic piston and void. Remember yesterday we have two technologies for the applicators. So B. So please read your document. Okay, B. Okay, so now which of the following materials are most disruptive for communications via UHF passive tag? Choose two answers. Very easy here. B and E. Yes, B and E. Water and metal. So are the any for 14 is yes, for 14 is B. Yes. B, Lisa, yes, for 14. For 15 it is of course B and E. Okay, B and E. So low frequency passive tags have a read range of about, yes, the lowest one. Muhammad, it's not B. Okay, A. Who told me B? They will not be. This 3 meter for low frequency, it's 50 centimeters. Okay, it's the lowest one. So a tag operating at which frequency can be best read through an animal or a human body? Yes, C, the best one. Okay. So which of the following is not an advantage of using an UHF RFID system? Which is not, which is not, which is not. As of which is not. Yes, this is an advantage, this is an advantage, this is an advantage. High data transfer rate, larger and larger read range, high data capacity. So the signal will penetrate through materials such as water. It's not true. The signal will be absorbed by water when you use the UHF. There is absorption, not diffraction or penetration. Okay? So A is not an advantage for UHF. Okay, so for which of the following applications will passive UHF tags not be suitable? Case level tracking at the airport, pallet level tracking in a warehouse, barcode reading, product tracking in a supply chain application. Yes, of course, C. Which will be the most suitable operating frequency for an application that requires closer reading and with a higher water content? High water content, it's evident, it's low frequency. Microwave water is not good for UHF and microwave. Okay, it's low frequency, A. Okay with that? Okay, so if you want to share with us who obtained 20? 19, 18, good, 17. So below 15, do not tell us, okay? 17, okay, 16, okay, 15. Okay, good. If you are more than 15, it's good. 15 and above. You succeed. If you have 15 and above, you succeed. But you need to read. I don't know. You didn't read your module, but it's good. If you didn't read and you obtain this score, it's good. Without seeing anything, and just with your memory. Okay, so today the topic will be about the regulations and so on. Not a long session today. So the RFID technology standards and regulations. Why we are using standards? Why we have regional norms, international norms, ear interface protocol, EPC global, which is very important, and the other standards. And we will speak about briefly about the privacy issues. Okay, so Okay, so this is the outlines. Why we should respect, we have to respect the regulations and the norm, because we will work in a global economy, and if you you do not put the rules, it will be impossible to manage the trade, to manage the exchanges and so on. So in a context of a global economy, it's important, it's critical to establish norms in order to allow to enterprises to have a consistent exchange with each other. Okay, so global economy is important because we are not in a closed system, and the changes are global, are worldwide. So it's also to avoid interferences. So it's important to put the rules in order to avoid interferences, because now you have many devices and networks and systems that use frequencies, and if you do not establish the norms, you will have the chaos. Okay, so you also put the norms and use the norm in order to select and to choose the right equipment for your application. So if there is no regulations and no norms, it will be impossible to select the right devices. So the norm, you will have an homogeneous criteria. You will be between and within the manufacturer. So it's important to have the same references to see if you select the right device or not. So, and then because we are dealing with radio frequency waves, it's important to limit the impact on users. So because the users are exposed to the radio frequency waves, so it is important to regulate this impact. And this is related to the first point, the effectiveness of the open loop configuration. So the open loop, it means that you perform business to business applications and business to business, or even the business to consumer, is worldwide now. With internet, you cannot expect to work in your ecosystem, closed ecosystem. So it's an open world, open for trading, open for exchanging, and then to make this configuration effective, so you have to establish the norms. And this is why many organizations, many institutions, many manufacturers and industries join their efforts to establish the norm that are used by RFID technology and applications. So for example, in Europe, and we take the example of UHF in France, for example, there is an organization which is called the European Telecommunication Standard Institute. And for example, this norm, the EN 302208, fixed the channels and the range of the frequency used in France, for example, and European community. Okay, so it begins, start with 865.6 until 867.6 megahertz for UHF, and you have the 10 channels here. So the band and the bandwidth of each channel is 200 kilohertz. Okay, between one channel and another, 200 kilohertz. And then you also have the maximum power you are allowed to diffuse. So this is 2 watt ERP. Okay, 2 watt ERP is Europe, the limit of the power you can send, your antenna can send. Okay, the equivalent and effective isotropic radiation power is 3.2 watt. So in US, this is the unit which is used. In Europe, it's effective radiation power. So just remember this; it's very important if you about RFID. Even whatever the using of the technology, you maybe use it for biometric. You can use it for logistic application. Maybe you can use it for very diverse applications, but this is the basic information you have to master. Okay, so this is the power of exposure, the limit of power in France and Europe, in Europe community. Okay, and this is channel in UHF. Why I focus on UHF? Because of the RFID UHF is the most widely used in the world, because the tags are very cheap, because of you can print the tags, and because it is used in the industry, and this is why. So the global market of RFID UHF is huge. It's very big. So billion of dollars and a billion of euros. This is why this is a big industry. Okay. So the impact of regulations, positive impact, sure. So the radiation effect, remember the specific absorption rate, it's very important, is ER. I think that you remember the formula. Proportionally to the square of, please answer. Directly proportional to the square of the SER. SER. Far from memory, Muhammad. Yes, electric power, you know, electric field, exactly. So you have to be precise, electric field. Okay, this is why it's important to regulate, because we are dealing with the electric field. So the positive impact has as a consequence to reduce the risk of our radiation effects and to reduce the interference with other devices. The negative impact of regulations, because you have negative impacts, it limits your freedom to do what you want. So when you put rules, you limit the freedom. It's known that this is the universal rule. Put rules and then you limit freedoms, but it is for the benefit of the global community. Okay. Okay. This is very important to memorize. There is the region. There is 3 regions of regulation in the world. So, and these regulations are divided in such a way, geographically divided, for everything related to telecommunication. So ITU is the International Telecommunication Union. Okay, it's worldwide. And these regions are defined by the ITU, which is an institution of the United Nations. Okay, so it is officially recognized, these regions. So Europe and Africa belongs to the region 1. Americas belong to region 2. Oceania and Australia and Asia, except of Russia, are in region 3. So you have to memorize these regions, the geographical division of these regions. Okay, if I ask you about France, you know that you belong to region 1 of ITU. And as I told you before, this is related to all what concerns the telecommunication, mobile telecommunications, communications, internet is region 1, region 3, region 2. It's for the telecommunication. This is the regions. Frequency of operation. I had question yesterday from Mustafa, and here you can have the, if the use of a given frequency is not allowed in the region of deployment. For example, you are in France and you want to use the 900 megahertz UHF. Okay, change the frequency to the closest permissible limit in the deployment location. So you have to change it, because usually when you buy a reader, you can change this this frequency to be conform, to respect the rules and the norms. So of course you have to select before buying these devices the vendors who can provide a RFID system that operate in the selected frequency. You cannot go to Europe and bring with you equipments working at 900 only megahertz for UHF. So after that, you can, if you for deploying, if you are using a frequency that is not allowed in the region of deployment, you have to apply for a license from the government or the authority institution governing this deployment. So the role of a standard is to regulate the communications between. So we have many type of standard, and you have to know some of them. Not all of the standard, it's impossible to know all of them, but there is important standards that is important to know, and I summarize here some of them that are important to know. So you have standards for regulating the communications between tags and readers. You have standards that regulate the communications between readers and applications and middleware. And you have standards that regulate and define the anti-collision methods. You have standards for defining the information encoded into the tag, for example, EPC and so on, all what we saw yesterday, for example, the banks and what we put as information into the banks and so on, is defined by standards. It's not just by users, or there is a really official norms and standards with a number of standards and so on. So to regulate the maximum power of equipment, so this is also defined by a standard. And of course, to ensure the globality, the global exchange, we have to put the standards to allow for the interoperability of equipment and applications to allow traceability, tracking, recall. If you have problem, for example, you imagine, so let's assume that you are a company and you export your products to Japan, for example, and then this is for example drugs, and and you put RFID tag in order to see, wow, where is your product, and until the end user, so until the final destination, which is in the client home. So, and then assume that you have a problem with this product, with a batch of products. So immediately you are asked to perform what we called a recall, un rappel des produits, a recall. So to be effective, this recall should should respect the norm and standard, because it will facilitate the communication. And we will see later how we can follow our product. If we haven't a protocol, we haven't a norm, we haven't a standard, we cannot recall our products and establish the communication that will allow for the recalling. Okay, so it's very important to have these standards. RFID systems are radio systems. Okay, so the function of the other radio system must not be disrupted. So it's important. And we know that we have restriction on using the available frequencies. If you are a company that is manufacturing and designing and producing RFID stuff, it's important to know you cannot just put your reader working at a random frequency. So you have to select the ISM. ISM, it's the industrial scientific medical frequency, but this frequency are regulated. So this ISM frequency ranges are all the frequency beyond the 135 kilohertz. Okay. This is why the low frequency is free of use, but if you go beyond 135, this is not free. So the frequency are regulated. So the ISM frequencies are the HF frequency, this frequency in general, okay, until the UHF, and then until the microwave or hyper frequency. This is what we call the ISM, industrial, scientific, and medical frequency ranges. There is the frequencies for communications, for ship communications, naval communications, for aeroplanes, and so on. So the standards, the RFID standards, we can keep the most important of them. We have the important one, which is the ear interface protocol. The ear interface protocol regulates the way tags and readers communicate. So this is to, okay, maybe using this is better. Okay. The ear interface protocol, it's important to memorize. Okay, so this words. Ear interface protocol are very important because they regulate the way tags and readers communicate. Okay. Then there is standards for the data content, the way the data is organized or formatted, like EPC, for example, PC number. The conformance ways to test that products meet the standard. And you have standards for the applications. So how the standards are used on shipping and so on. So the institutions, you have the famous one, which is the International Standard Organization, ISO. You know probably this organization, which developed standards for data protocols that support selective read and write of data and common encoding rules for a number of air interface standards. So in RFID technology, ISO is involved in the air interface protocol mainly, but there is another standard. So we will see example later. So you have also EPC Global. EPC Global involved in the development of industry-driven standards for the electric product code trademark to support the use of RFID. So this is the institution who made possible the use of RFID globally, especially the UHF, and to perform the global trading network using RFID. So let's start with the air interface protocol. The air interface protocols, these are rules by which the communications are transacted between the interrogator and the tag. And the air interface protocols cover bit encoding, rules, and essential commands for reading, writing, amending, and locking data. So these rules are embedded into the air interface protocols. So let's see this illustration. So here you have the reader, you have the middleware in the application, which is hosted by the computer. You have the reader here, and you have the tag here, the radio frequency tag. Into the tag, you have the memory, you have the antenna, and here you have the reader, and in the reader you have two parts. You have the physical part of the interrogator and the part which is soft, hard and soft, and you have the data protocol processor here, and to process for processing the data. It's a low level, high level. Okay, so when you have communication between tag and reader, this is the physical interrogator part which is involved to do this communication, okay, to send comments, to receive the response with the antenna. This part is also connected to the antenna, okay. The antenna is connected to the physical part of the interrogator, and then the air interface protocol is here, is between the tag and the physical. And you have here the ISO standards. This is very, very important to know. So if I tell you the number of the air interface protocol, you have to answer yes. This is the 18,000. 1, 2, 3. The X stands for 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so I can show you, yes, here. So you have the 8000 standard is for the air interface protocol, and it is very important. And then you can replace X by 1, 2, until 7. I think you have 8 too. Okay. And all the standards related to the physical interrogator are into the norm, the standard ISO 15962. Same for the data protocol processor inside the reader, the same. So you have two parts. And then the communication between the reader and the application, within the high-level application in the host system. So you have the device command, the application command, the application response, device response. So you have to manage the reader. In order to manage the reader, you have application that manages the reader, and these applications that launch the device, the reader commands, and so on, which is connected to the logical memory of the reader, to the command response unit of the reader. All of these communications are regulated by the 15,961. So you have 61, 62. You have also 63, but it's for other things. So these are to remember. Okay? You have to remember this. And all the stuff I give you in the course here are very important to know and to remember. Okay, all the numbers. So the ISO is the International Organization for Standardization, and you have also the International Electrotechnical Commissions, which is involved in some of these standards. So if you have ISO 15,961, 15,962, so the protocol of the interface between data and application, and defining the tag memory content for encoding the item label also. So the 1560, for example, another standards, 15,693, it is related to the physical features of the inlay. So all the features related to the inlays are regulated by this ISO now. Please tell me what is the inlay, please, in 2 words. Could someone tell me what is the inlay? Yes, Hina, you are close, but it's not really the. Be very, very precise. 2 words. 2 words. Don't see your documents, please. Yes, Watara, but you are just. It's very fuzzy what you are giving to me as information. Just you are. So be very clear, very clear. The inlays you have. Yes, it's in the electronic. Hina, you are close, but maybe I will retain only 1 word from your proposition. Good, Lisa. Yes, IC and the antenna. Simple like that. So in the tag, you have the integrated circuit and the antenna. This is the inlay. Yeah, Mustafa. Electronic circuit, it's very general. Okay, I don't see that it's false, but electronic circuit, it's to be more precise. This is the integrated circuit and the antenna of the tag. Okay. Okay. So good. And this, the size, the dimension, the materials, the frequency, all of stuff related to the inlays are regulated by this norm, this standard of ISO standard. You have one to remember, because usually we ask this in the professional test, the ISO 10374, which is the thread container identification using the active tags. This is for active tags, and this is for the transportation, and all the transportation using the active tags are regulated by this standard. Okay. So the air interface protocol, 18,000. 18,000. You have 18,001 generic parameters, globally used frequencies, and so on. So this define this. 18,002, the communication at 134. 13.56 megahertz for HF. Microwave 1 for this frequency of microwave. This frequency for microwave 18,005. UHF, you have 6. It's very important to know. 18,006 communication at 860 and 960. And there is another high frequency RFID, very rare, which is regulated by 18,007. The global architecture of RFID solution. So you have layers and you have the devices, the data and collection management. And you have the event management, you have the services, and you have the applications and solutions. So it's a logical distribution of the tasks and the applications from the devices, physical devices, to the application and solutions. Okay, so maybe it comes the time to take a break. So maybe 10 minutes break, or between 10 and 15 minutes breaks. Is it okay with you to take a break now? Okay. So I will just pause the resume our course, guys. Okay. So the global architecture of the global RFID solution is organized into layers. The low level layer is related to the devices. So you have the RFID readers, the barcode scanners, the application, the pocket PC, the handle terminals, and so on. So all, because now even if you have a phone, a cell phone, you can have an application. It can be used as a handled reader and so on. So the data collection and management, this is the layer 1, to manage data collected from these devices. And then after that, you have the event management, so the workflow in the company, the business rules, the messages, and so on. This is layer 2. Layer 3, we have the analytic reports, for example, the inside enterprise content solutions, the business process management inside many services of the enterprise, and product information, and so on. After that, you have solutions that are, for example, can be used to real-time providing, for example, with suppliers and providers. So you have a connection in the solution in order to perform, for example, stock management and inventory management after seeing the business process, the event and business rules, and so on. So this is highest levels of information. You have another specifically to the RFID, you can have this organization, which is used mainly by the Department of Defense, US Department of Defense, which is the organization, the most advanced organization in applying RFID. So the Department of Defense use RFID in all its logistic structure, and there is many standards related to these layers. So the logistic organization, it is similar for other organizations such as Walmart. Walmart is a big company selling foods and other goods like Carrefour, but it's worldwide company like Carrefour also. But you can have also this organization of the logistic units, and all these organization are, as I said you before, it's important that there is standards and norms at every level of integration. If you do not have this type of standards, it will be the chaos. It will be not possible to do the worldwide trading, the global trading will be impossible. Okay, so the layer 0 is defined by the ISO 17367, and this is also the standards, the first organization which defined this which is the basis of this standard, is the Department of Defense, US Department of Defense. So because they have the lowest integration level, it is on item. So item could be soldier, could be goods, could be foods, could be drugs, and so on, could be weapons, and so on. So this is at the item level. Item level is the lowest level for integration, for RFID integration. After that, in layer 1, you have the package, the packaging, the box, and this is box that in this box you can have many items, and you can tag this box, and the standard for that is 17,366. Okay, so this is to regulate this packaging. After that, you have a transport unit. Transport unit is a highest level compared with packaging. So the transport unit could contain many of package here. So of these packages. So this is regulated by the ISO 17365. Okay. And after that, you have the pallet unit. Pallet unit, many, so this is in highest level of integration. Many of transported unit can be embedded into Unity pallet. And then Unity pallet you have ISO, but you have also ANSI and EIA, which is mainly American Association, Electronic Industry Association, and American norms. ANSI, you know the ANSI, it's same in computing, and ISO. So this is the norms, the standards that regulate the Unity pallet tagging RFID. After that, these pallets can be into a container. So the container, the standard is 17. So this means that if I put container here, we speak about container here, it means that you have a tag here, maybe active tag here. Okay, so this is fixed by the ISO 17363. So at each layer you have a target, a tagging process, RFID tagging process. Okay, so the container is follow this ISO standard, and after that the transport. So you have You can transport these containers by plane, by train, by ship, by so this is regulated by remember the one we saw before. So 10,374. 10,374, it's freight container identification. But it is also related to the way of transport with plane, train. This also regulates this means of transport. Okay, so it's very important to have this type of standards. However, we can work into the closed loop. Closed loop, it means that you are in your company and you can use RFID inside your company, and that's all. This is possible, and we have, for example, in our labs here, we are not connected with, we do experiments with others, but mainly we can do our, we manage our library with that. Yes, I told you that I will show you the tags. So I will take 5 minutes to bring you tags today, or maybe tomorrow, but I will bring them today. The plastic tags to put them onto metal UHF RFID tags. Okay, so you can work inside your company. The configuration is called, the architecture is called closed loop architecture. So you have the middleware. Middleware is the software managing your applications connected to the readers and to the tags, and then you filter the data, you route the data, you track and trace your products, and you can use a warehouse management system, and you can use internal database, and this is great. In this configuration, you are autonomous, you are free, you are independent to do the applications, to reuse the tags, and to do many things, but you are not connected to the world. Okay, you cannot see, zoom out. Okay, is it okay, Lisa? It's better, or I can reduce to, if you want. This is better, or but this is, it seems me small. Okay, maybe it's is it okay for everyone? Yes, this is why, Lisa. I think I will just augment one level. This one, it's smaller than before. Okay, now, okay. Mustafa, okay for you? Okay. So this is the closed loop, and this is the open loop. Open loop, you are connected with the others, and this is mandatory to have standards and to follow the standards. You have readers, you have tag, you have the reader connectivity, but you have a business-to-business application integration. So you have a process management to do, and you can be worldwide partner with others, and you have business partners everywhere in the world. You still be connected to your warehouse management system, to the enterprise resource planning system, ERP, like SAP and so on. You have internal database and external database to deal with. So it's very important to follow standards here for the open loop. Okay. If we see the closed loop application. We can use it to identify and track within a company. So it's important here to see within a company, inside the company, and or on the same site. Okay. So standards and norms are not required if you are in closed loop applications. We have the possibility to reuse the tag, to change the number and to reuse the tag. The applications, not EPC, not EPC, but to all the informations related to the tags, we can, for example, we can use the tag for computers, and then if you want to manage something else, books, or you can take the tags and use them for the books and so on. Okay, but because you are inside your company. The applications are production monitoring, quality control, warehouse management, shipping. We have for your purposes, and localization of products within the site. So this is the application into the closed loop architecture. The open loop applications identify and track the products on a logistic chain. Logistic chain, that means that you involve several enterprises. So you have partners. The tags are not reusable, impossible to reuse the tags. The information is shared within partners. So the applications, order picking management with your partners, logistic flow management, traceability and tracking beyond the enterprise, and product recall management. You can perform the recall management too in open loop applications. So remember, open loop and closed loop applications and architectures. Now, how these standards and the norms are managed by the manufacturer, by the industries, by the organization. We saw that we have ISO as an organization for the standards, but to manage the exchanges, to manage the information management, the information sharing, what we will see from now, it's the beginning of what we call the Internet of Things. I gave you the lecture for that. The Internet of Things, it means that you have access to all information about your tagged products, tagged items, tagged reader, everything, thanks to an internet network or a global network, where you can have access to a tag. Of course, if you are in this configuration, you are in open loop configuration, open loop structure. And to do this, it's an old dream of many organizations to have access to, for example, a vendor sold you, for example, a computer or cell phone and so on. So if there is a tag in your product, the seller can see in real time where is the product and the state of the product, the feedback from the client, and because he can have access to this information, just like internet. You have information pages on internet, but here you have access to the product, and you can access even to the bank one of a personalized user memory if you are allowed to do this, and you can access to all information about the products and the tags. So this is a dream, and the dream came in reality these recent years. And there is many organizations in Europe and US mainly that worked on that. And here I'll give you some of this normalization or effort to do the homogenization of norms, and to have the possibility to have a global platform like internet to access to all the objects that are connected to readers, and this is the beginning of Internet of Things. This is why we call this Internet of Things. So you have the Uniform Code Council, UCC, which is an organization that supervises the Uniform Product Code. This organization in US and Canada is the organization which is mandated for managing the barcode standard. Okay? So UCC. All things concerning the barcodes were managed by the UCC in US and Canada. The same organization or similar organization in Europe is EAN. EAN, it's European Article Numbering. Okay, so the beginning was with barcodes, okay, which is universal. So you have the background for that. You have the background for globalization of trading because you have the barcodes. So the two organizations unified their effort and create what we call GS1. GS1, formerly it is called the EAN and UCC. UCC in US and EAN in Europe, and they create the GS1. But US, as you know, has its own like to keep its independence from that. So this is why they create GS1, and UCC in the US and Canada is called GSUS, and in Europe you have GS1, GS1 US and GS1, but it is GS1, which is giving the norm. And GS1 and EPC Global GS1 codify the RFID system and create what we call the EPC code. Okay, codification system which allows the organization to identify any object uniquely. This is very important, and this is the beginning of the Internet of Things, EPC code. So there is also the beginning of establishing a network to share information that give more visibility for all partners through the supply chain. Okay, just to consult and to make a retrieval and to retrieve information, and you can have access to the EPC tagged products. So the global EPC network, the EPC Global, that is managed by GS1, is like this. So you have drugs, for example, you have EPC, you have a reader. The EPC about these products is filtered and is managed by the EPC information service, local information service, EPC, into your enterprise, your company. And you can share also this information thanks to these applications. This is the local database where you manage the information about these products. But you have in this application the EPC Global Network, the Global EPC Network, which is composed of mainly 3 services. I want you to remember these 3 services. So I will underline these services. you have the EPCIS, the ONS, and the EPCDS. So EPCIS is stand for Information Service. So the Information Service. It could be local and it could be remote. Okay, remote it means at a distance. Okay. So you have information service, local information service. It's the information system you have in your enterprise managing the information. It's the middleware, could be the middleware of the hosting computer we saw earlier. It's the EPCIS. ONS, it's object name service, object naming service, okay. And you have the EPC discovery service. The object name service is related because we want to design an Internet of Things. It's exactly like DNS. You know DNS? Can someone tell me what is DNS stand for? Yes. DNS is stand for what? Domain name solving. Okay. So what is the role of DNS? Name service, yeah. What is the solving or service? Solving, I think. It solves the domain name. What is the role of the DNS? Yes, it matches the IP to the domain name. Okay, so it avoid to us to use IP to connect to web pages. So we use names, but the matching is done by the DNS. Okay, because in the reality, the server is defined in the internet by its IP. But for us, it's more practical to have a name and to do this matching. This is DNS. Same thing for objective name service here. So this is take the EPC code and so on, and then if you want to access remotely by internet to this product, you use internet pages using ONS and DNS. DNS is used. Why? Because you can have the IP of this reader, and the IP of this reader is connected to this company, and then you have to do a mix between IP of the reader, the name of the company, and then to provide the ONS. Okay, so ONS benefit from DNS, and this stands for object name service. Object naming service. This is avoid for the user to use of the use of EPC numbers as numbers, but using name instead, like DNS for internet. Okay, so ONS is very important. Okay, discovery service. This is the comments and the codes and that allows for the searching and for managing the URL the devices connected by RFID. And here you can use like HTML, you can use what we call PML. PML. Like HTML, it's product markup language. And you can manage your hypertext, links, and so on. Donc, here we have this global EPC network that allow for Internet of Things. So the global ONS object naming service features, the system uses the EPC code of an object, which is a number, to perform a request to the object naming service through the EPCIS, okay, local EPCIS. The object naming service is a system which allows the information related to an object having an EPC code. Okay, in reality, the matching is done between the EPC and the web page, like IP with a web page. But we use also the DNS. The DNS is involved in ONS because we have the infrastructure for that. We already have the connections. Okay, so we use DNS because we have to deal with IP. The reader has an IP, so you use also a DNS. The object naming service system returns the IP address of the EPC discovery system server capable of giving information on RFID tagged object in the cloud. This is what I told you before, the discovery service, the EPC discovery service. So give all information about the object in the cloud. Okay, so this is an information, and this information is coded into PML. So you have many PML. It's like HTML, but it's related to objects. It's based on XML language, like HTML. I have, I think I have something to, maybe this figure. Is it okay as a size for the image here? Okay, Mohammed, Lisa, is it okay for you? Bit small? Lisa, is it good? I increased the size. Okay, so here you have good. Okay, here you have the physical layer. You have the RFID readers, the EPC tags. You have the reader protocol. You collect this data by the antenna, the reader's antenna. Then you have the EPC middleware software. You manage your readers. You filter the data. You select the products you want. And you have what we call the ALI interface. ALI interface is application level events management. It is developed by MIT in order to do all the coding procedure to manage the information collected in the middleware to the EPCIS. This is developed in 2005 by MIT University, and it is known as ALA interface. Maybe let me, I can show you what is looks like. we can share the screen. Okay, maybe maybe I can share the screen just to find where I can share the screen. This is maybe media player screen. Okay, yes, I found it. Start screen share. Okay, you have to stop your webcam. Okay, start. Oh, it's not possible to do it just this way. So maybe I will, let me just a few seconds, I'll do something in order to show you the LA, just few seconds. So let it upload and then we continue. So then after that, you have the EPC information service server here, and you manage your application with your partner. So another EPCIS, which is also a server of application of your partner, and you have a local object name service if you are managing your access to your information, and you can have a honest globally an EPC DS discovery service and naming service. So EPC Global powered by GS1 EPC. So the LA, it's a specification. So you can access to this document in order to see all what is related to the management of application from readers to middlewares. Okay, so three components important to perform the EPC Global, to perform the Internet of Things. Okay, so the EPCIS, EPC Information Service, Object Naming Service, and EPC Discovering Service. So The ONS system returns the IP address of EPCDS server capable of giving information on an RFID tagged object in the cloud. The EPC Discovery Service is a service of the EPC Global Network that allows the companies to retrieve and find any RFID reader which communicates with a particular tag. So it's because in fine you have the RFID reader which is connected to the tag. So you can use the PML, Product Markup Language. EPCIS is a distributed platform that enables companies to store information in the EPC database through the web service. EPCIS has different levels of secure access that enable companies to share product information with different groups, customers, partners, suppliers, and it's an information server system. So EPCIS, EPCDS, and ONS. The PML markup language, I thought physical markup language, physical, not product. Physical markup language is used as a common language within the EPC global network to define physical object. The PML is based on the extensible markup language, XML, like HTML, that is increasingly used on the Internet of Things to facilitate the exchange of information. The idea is to create a language adapted to the supply chain management, so that more effectiveness is brought to the inventory. So the PML server is a server which responds to the request formulated using PML related to the EPC products. So the EPC global summary, you have the tags, which contains the data and carry the EPCs, the electronic product cards. You have the reader, it's the data capture device, EPC, electronic product code, the seventh, which is the servers, which act, you can see this word, seventh is the servers, which act as a local repository for EPC and associated information, and which support a sophisticated flexible middleware for service PML. So here you can have EPCIS and EPCDS, and then the object naming service, the distributed resource that knows where information about EPC is held, just like DNS, and the PML, which is the markup language, physical markup language, that allow to use structured language to access to the information. Okay. So this is the background for you certainly heard about the Internet of Things, UIT, and this is the background for that. So RFID is very important today because of this. So you can have information about your fridge, about your TV, about your books, about your computer, about the stuff you have in your house, and it can be managed like internet pages. So you can imagine that you can have applications for example, to have a smart kitchen, for example. You can have at every moment in real time the goods that are needing for your kitchen, for example, because you tagged everything and you know that everything is tagged. So the provider automatically will provide you with all the stuff you need, without inquiring about seeing if really you missed that or not. So everything converge towards the smart applications that increase the quality life, the life quality, and then so you in real time. So this really is a little bit scary because you know that the frontier between privacy and smart applications and sharing information and so on is very, very thin. So for the current society, for the citizens of today, this is a really big issue. It's a trade that is that should be addressed in the society and all members of our society. If you are in the position where everything is known about you, about your needs, about your medical records, about your drugs, about your money, about your it's a little bit scary. So this is why it's an important issue which is discussed in many universities, and many scholars discuss these issues that are not a simple issues. It's very towards which word we will go tomorrow. If we, and the RFID is a critical technology, is dramatic technology for that. It's a technology that which is in dramatic growing. So it is growing, and it is ubiquitous. It is in our real life, in everyday life, and this is an issue. And I want to know if for you it's important to discuss this in our society. Is it for you a problem, the fact that we have everything known, all information about citizens and persons and their needs, their belongings, their private life, because we can extend the applications. There is no limits to access to these informations. I want to know your comment about that. How you are feeling about that? Are you for the diffusion, the application for everything, everywhere, and to have more and more smart applications? It will be great. It will be exciting because it will ease our life. But are you agree with this vision of the world? For you, it's okay, Hina. Okay, it's very scary for individuals' private life. Yes. And here in Canada, there is many theses, many discussions in universities about this. So yes, yes, of course. If you have this technology disseminated in all our aspects in our life, there will be attacks and to these informations, and you have hackers and yes, yes, this make our life easier, yes, but just think about the passports, the smart cards in your bank. So it's impossible for a human of 21st century to be free really in his and her movements and so on. Yes, Watara, yes, I agree with you. But if you improve the healthcare systems, you can imagine that this information about your healthcare condition could be shared with another person or another organization. And this will limit, if you have a healthcare condition, problematic healthcare condition, maybe it will be considered when you are applying for a job or applying for to have a loan, bank loan, or so. This is why you have, yes. So no, but we have to be a very conscious citizen to impose laws and regulations and protection. It's very important. And for me, it seems that we neglect this aspect. So we have to be a responsible citizen to make restrictions and law restrictions for that. There is security, but also there is privacy issues, Herzog. Security, it's mainly a technological problem. You can ensure the security, but after that, even if you have security, but if you have organizations or that are able to access to this information, and mainly maybe you sign for give them this authorization, and after that this information is used for so this is why this is the link of what we will see now about privacy and issues, privacy, information sharing. Yes, so you have to, maybe in the near future you will be involved in some legal and rules, and so be aware about that. So we have, as a citizen, as a world citizen, as a responsible citizens, to put the real, because we are the persons who are aware about that. The common citizen maybe do not know this, but you as responsible scientific persons and who know about that, you have to, yes, it's government. Government have access, and organization, not only the government, could be private organizations, and like in healthcare and insurance companies that can use this data, you know, and to limit the access to some services because the health condition is not good and so on. So there is diverse issues and threats. So this is lead us to yes, but it's really it's absent now, Watara, in the legislative groups and so on, in parties, and this kind of issue is really absent. So it's time to discuss this because it's very important. Okay, so let's now so the best practices guidance for privacy, respect, and the source, I found a very interesting document that you can use in your country and everywhere you want, is the Information Privacy Commissioner, Ontario, Canada. So the RFID privacy guidelines apply to any organization that uses an RFID information system or service dealing with personal information. It's very important. So wherever possible, efforts should be made to minimize the linkability of RFID tags with personal information. This is the first law. It's very important to disconnect the linkability of RFID with personal information. This is important. And usually this is not the case. This is what it's important to have regulation about that. So the RFID information system should be open and transparent and offer the possibility to the involved people to be continuously informed. So if you are somewhere, your information is saved somewhere, you should be able to have access to this information every time, everywhere. So, and there is some important principles to respect. These principles are as follows. First of these principles is accountability. Accountability is an organization is responsible for personal information under its control and should ensure privacy and security regardless of where the RFID tagged items originate or end up in the product life cycle. So this is the responsibility and the accountability of the company dealing with RFID tagged items. Okay. So the second principle is identifying purposes, the goals, the purposes of the organizations. So the organizations should clearly identify and communicate to the individual the purpose for collecting, linking to, or allowing linkage to personal information in a timely and effective manner. Okay, so you have as organization to identify the purposes. You have to get the consent. The consent organization must seek individual consent prior to collecting, using, or disclosing personal information linked to an RFID tag. Consumers should be able to remove, disable, or deactivate item label RFID tags without penalty. So these principles are very important. The fourth principle is limiting collection. The information gathered or collected should be limited to the minimum needed to fulfill the stated purposes, with emphasis on minimizing the link of any personal data of the tag. This means that we do not collect everything, but just only what is needed as information. Okay, so this is the limiting the gathering of information. We also limit the use, the disclosure, and the retention of the information. The organizations must obtain additional individual consent to use personal information for any new purposes and securely destroy this information if not needed. Okay, very important principle. The accuracy. The personal information is maintained as accurate, of course, after your approval or after approval of the user. So the information should be accurate, complete, and up to date as is needed, especially when used to make decisions affecting the individuals. So we spoke about healthcare condition. This information about the health condition should be accurate. Safeguards. Protect personal information linked to RFID tags against you are responsible for the loss or for the theft of this information. So you have to protect the personal information which is linked to the RFID tags against the loss or the theft, and against unauthorized interception, the access, the disclosure, the copying, the use, the modification, or the linkage. So it is the responsibility of the companies and organizations that are dealing with the RFID, that are linked to the personal information, to provide all good conditions to avoid hijacking, for example, and to avoid the loss of information. Very important. The openness of the system, information about policies and practices related to the operation of RFID should be made available in a form. This is a form, it could be a virtual form or in a form that is understandable to the individual. So after that, we have the challenging compliance. Organizations should have procedures in place to allow an individual to file a complaint. So if you want to make a complaint, you will be free to make a complaint concerning the compliance with any of the above principles. Okay, the right to make a complaint. So in conclusion, okay, Hassan, let's see your the first and third principle. First and third rule. The first is accountability. An organization for personal under its control should ensure privacy and security regardless of where they are. I don't think so. What do you mean by organization? Because of a link between the person and the tag. But you agree for that. This is what I said. It doesn't mean that you never have information linked to. You have also a tag that identify person and passport identify person. This is the purpose, and you agree with that, and you do that, and you okay. But for example, you buy maybe I give you another example. You go to a mall and you buy maybe let's see maybe a cloth, and you have a very expensive cloth, for example, and you have a RFID tag, and then when you buy this tag, you didn't see anything to the seller, and then the seller, because they use your card or your payment card, or you they introduce some information, and inside the tag you can make the link between this cloth and your without your consent. So it's not permitted to do that. But if the purpose is to identify the person and the level of information, private information you provide, you approve that, and this is the purpose of that, it's okay. But the link, if you maybe for drugs or for foods or some, you can put information, you can have information, and the information, because the personal information on the individual is not requested, not necessary for the process. So the link should not be present. Okay, Hassan. But if the purpose is to identify the person, of course you have to. But the third, you give your consent for the passcode to use it, and the purpose is really here. Okay. So it is necessary to respect the standards and norms. So an advice, if you plan for RFID, just think about open loop configuration because we are in a global world, and do not think about closed configuration because it's not possible today. And in order to benefit from all applications of Internet of Things and so on, it's better to think about open loop configuration from the beginning. For example, if you buy tags, for example, do not think about yes, I am don't think cheap to have just a few numbers of tags and then to reuse the tags and so on. Just from the beginning, think about open loop configurations. So do not reuse your tags, do not and this is good because if you want to extend your activity, or it will be easy for you. Don't from the beginning think open loop configuration. Of course, if you think about open loop configuration, you have to follow the rules and the norms and the standards. For UHF RFID, the company used what we call the EPC Global UHF Gen 2, Generation 2, which is very famous and very known and very popular. And ISO for UHF Generation 2, the ISO 18060 C standard, known for UHF Global. The item management standards, so, and the retail standards. So the UHF is maybe the UHF RFID is the technology which make a great increase and growth these recent years, and this is why the most part of the standards and rules are related to UHF RFID. So, and after deploying your RFID, make sure that the privacy guidelines are respected, and to be a responsible citizen about that. Okay, so today it's not bad because we finished before the disconnection. Okay. Do you have questions, comments about everything we saw these 3 days? Tomorrow you will have also a quiz, and do not forget the lectures, the summaries. Any questions, any comments? Preferably one pager. Yes, this is challenging to have it in one page for each lecture with your own words. Yes, Lisa, it's this is why it's no, one for each lecture, not my lecture. Maybe I call them lecture, but this is the article and papers I gave you. For each, yes, for each in the platform, yes, are in the platform, articles and papers, yes. You no, there is 3. Mohammed, just confirm. Yes, 3. Sayyid Muhammad, just confirm, please. Go to the electronic platform. Not here, but in the electronic platform. Yes, the e-learning platform. One for each, one page for each, with your own words. There is very interesting papers. These papers will give you the complementary knowledge about the RFID. And I think if you memorize your content, of the courses we gave you these 4 days, you will be able to really to pass the professional tests. Okay, Mohammed Sayed, did you find the 3? Okay, good. Good. Any question? Okay. So hope that you benefit from this course, and I think that yes, it's very important technology to understand and to. So after that, you will be able to learn more and to search more and to have additional knowledge. Yes, tomorrow quiz. I need the 20 on 20. We have to read these slides. Yes, 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 yes. Yes, but 20, not 15 or less, huh? Without seeing the documents. Okay? No, it's a joke. Just prepare and okay. So see you tomorrow, guys. And then today I'm very happy because there is no disconnection. But I think Lisa told me yesterday that there is only 3 hours. So sorry about that. I thought that we have 200 minutes. Okay, so see you. Bye.